Hello YouTube, hello Thingiverse. This video is going to be about my latest and greatest gear ratio ever, 1,379 to 1, and it fits in the palm of your hand. With two of these gearboxes in series, the gear ratio is 1,901,641. I'm going to start this with a brief introduction into how differential planetaries work, and I'll also touch on assembly for those of you who want to print your own. There's going to be a link to the Thingiverse files in the description. I'll be testing the gear ratio of this gearbox with the stepper motor, and I'm also going to run this with a cordless drill and record with a thermal camera so you can see the kind of heat that comes off of this gearbox when it's running. A differential planetary is a combination of two different but very similar planetary gear sets, with one major change from how a planetary gear set is normally used. In a differential planetary gearbox, the gear ratio is actually derived from the difference in number of teeth on this ring and this ring, or the difference in number of teeth between this end of the planet gear and this end of the planet gear. The combination of changing the number of gears between those two will give you your output gear ratio. Now you may be thinking that this is a harmonic gearbox and the ring gears are flexing, or that I did something with mismatching the module of the gear teeth to make them fit together the way I did. But I assure you that's not what's going on here. If you're interested to know more about how these differential planetary gear sets work, I did make another video on it earlier in my channel. You can go and check that out. To be honest, I can't explain the exact science behind this thing. I can give you a calculation if you want on how to get the gear ratio, but that's about all I know. It's very, very hard to explain. I'm going to take this thing apart and show you guys how to assemble it. If I can get it apart. It's very hard to disassemble, so when you assemble it, just make sure that you don't ever plan on taking it apart. So this is all the necessary parts you need for this thing. This holder thing is kind of useful to have. You don't absolutely need it, but the problem is if you don't use it, this thing will pop apart and your gears go out of alignment. This thing, same deal. You don't absolutely need it, but you need to find a way to hold this ring together, because this ring will pop apart while you're trying to run it and your gears will yet again go out of alignment. These two sun gears are different. I put both of them up on Thingiverse. This one is for the stepper motor. This one is for if you want to drive it with a drill, or you can use this to put two of these gearboxes in series. So this would drive the second one and this would be the output from the first one. This thing, if it's not long enough for you, just remember you can always scale it in this direction, make it a bit longer. So you could mount two gearboxes in series on this, or you would definitely have to make it longer if you wanted to use the NEMA 17 mount and two gearboxes in series. For this one, I'm not going to use this sun gear, so I'm going to set that off to the side, and I'm going to assemble this thing. I left marks, I don't know if you can see this, but I left marks from the straight across this planet gear, and then they go right into the sun gear, and then they also are marks on this ring too. So first off, what I like to do is I just line up number 1 gear with its mark, and then I put number 2 gear on its mark, and then line that mark up with the outside of the ring. And number 3. I'm not making this look as easy as I wish I would have. Okay, so I got number 3 in there. Alright, so I got all 3 gears lined up on their marks, outside and inside on the sun gear. That's really helpful for aligning these gears inside the gearbox. Otherwise, you could spend a lot of time hunting and trying to get them in place, but the marks really made things easy for this. So after that, I'm going to go and put the number 2 sun gear in, or the driven sun. This gear actually does not need to be in this gearbox for it to function. All it does is hold these planet gears from being pushed in from this back ring. So the last gear to go on is this ring gear, and to put it on, to know which way it goes on, there's a beveled edge on this side, but you can hardly tell because I actually printed it laying down this way. But If it engages on the back gear halfways, then you actually have to flip it around. That's great. I damaged my gear when I pulled it out from when I disassembled it before this. Okay, so after that, this is the easy part. You take this cap here and you pop it on, take the gearbox and mount it in this channel, and then you should be able to spin it. Now this one's spinning really rough right now because I just damaged the gears because I had to pull them apart to show you guys how to put this thing together. But I do have this one, and this one spins a little bit better. So now I'm going to set up my Arduino to run this thing. I was trying to set up my Arduino board to play that song Tear Down for, or not Tear Down, it's Turn Down for What? So I was trying to set up my Arduino board to do that. Here, I'll give you it closer to the microphone. I was really just going for the right notes there in the first few notes, but I never really finished that. So I'm going to load the program on here to test this thing 1,379 to 1. So the motor will turn that many times. First off, I'm going to have it spin. I'm going to probably do 1 or 2 rotations just to show you that the shaft ends up in the same spot every time. Then I'm going to go for the full 1,379 to 1. I probably will fast forward through this part because it could be kind of boring, but anyways. Okay, so I'm just uploading an Arduino program to tell this shaft to turn 1 revolution exactly. I'm going to make a mark on the stepper motor right there, so we know what that shaft is. Okay, and then I'm going to make a mark here and a mark here. Arduino program is uploaded. Let's turn on the power supply. So this should turn 1 revolution and stop. Perfect. And one more time. So now I'm going to tell it to turn 1,379 revolutions minus the 2 that I just ran, so that it should end up in exactly the same spot it was before. 1,377 revolutions. Ready, set, go. So as you can see, this output ring in the back is turning. That's the ring that's rotating. This ring is staying stationary. The planet gears are twisting around the center. Stepper motor is still accelerating. too bad the Excel stepper library doesn't have a minimum speed. That'd be really useful in this application. Okay, it's time to spin this gearbox with a drill. Notice that every time I put this number 2 sun gear in, it actually goes slightly off center. It's just one gear tooth over here or here, and I found the best way to fix that is actually to line it up by going like this and then skip it until it's centered on this other sun gear. That seems to work the best. So now, for every 1,379 rotations of this input shaft, this output shaft spins once. And for every 1 rotation of this output shaft, that input shaft spins once. So for every 1,901,641 rotations of this input shaft, this output will spin once. I am expecting the sun gear and this gearbox to get the hottest out of any other gear. And that's from experience. That's what I've seen with every other one of these that I've tested. The sun gear gets warm, and that's why I feel it's important to print it out of ABS. This is actually all printed out of PLA, so we'll just see how this stands up. Alright, got the automatic trigger holding device in place. Alright, 3, 2, 1. So it does appear that the sun gear is the warmest, and it actually appears like the sun gear in the back is warmer than the one in the front. But hard to tell. About 100 degrees Fahrenheit. And on the gearbox, the second one doesn't appear to have moved hardly at all. The first one has made maybe 4 or 5 rotations. But 4 or 5 rotations isn't much when you got 1,379 to 1. So, besides the large gear ratio gearbox, this is the other project that I'm working on. This is a it's intended for very high torque. But it's a very low gear ratio, actually. I believe it's only 30 to 1, which I could have accomplished with a different type of gearbox. But I like this one. So I will be releasing files to this soon, but I gotta fix the problem with the sun gear first. I had a really hard time separating the sun gears in this. And they print out as one piece, so it's like a print-in-place sun gear, but they gotta spin different speeds, so it was very hard to separate them. I think I might have fixed that, but I still have to print it out and test it, and then I'll release this one. You guys can have it. I don't know what you would ever use it for. I don't know what I'm going to use it for, but it's yours if you want it. So there's that. So yeah, thanks for watching, guys. 1,000,000 to 1 gearbox. Really high torque. 10 or 30 to 1 gearbox, if I remember right. Well, I don't remember right. Yeah. One more thing, this gearbox is not designed for torque. I'll show you guys the failure mode on this. I'm going to hold the output on this gearbox and I'm going to spin the input until it self-destructs, and I'll show you why this thing can't handle torque. This one specifically, where this one can. So that's the failure mode on this. You see how the planet gears are in there crooked? They keep doing that until eventually they, the gears just grind their teeth right off, and it actually slows down the drill. It takes that much away from the input when the gears start going crooked in there like that. And as you can see, I broke the end right off of it. So that's why you can't use this specific gearbox for torque. If you want to design a differential planetary for torque, you have to do it this way. You have to have more than 2 modules. You have to have at least 3. So in this one I did 6. I was going to see if there's any advantage to that. So while I'm out here doing all this different testing and stuff, you guys can be printing this stuff up and using it for whatever you could think of to put it in. So thanks for watching, guys.